surface. Okay. All right. So in our previous lecture, we have learned about standard electrode potential and cell potential. Okay, so in this subtopic, you have learned what is electrode potential, and cell potential also has been introduced in this topic, in this subtopic. Okay, but we will get into the calculation part, okay, in a bit. So for an electron, for electron to flow, okay, from one cell to another cell, it need to have the cell itself need to have the difference in potential. Then only it can drive the electron to move, okay, from one half cell to the other half cell, from the oxidation, okay, half cell to the reduction half cell. Okay, all right. And you have been also introduced to standard electrode potential. Okay, the word standard means the reaction is conducted at standard conditions. So what are the standard conditions? Okay, the temperature need to be fixed at 25 degrees Celsius, the pressure need to be fixed at 1 atm, and the molarity, the concentration of the ions, should be at 1 molar. And not to forget, the electrode potential of half cell depends on several factors. So like what I've mentioned to you just now. Okay, so it depends on the nature of the electrode, temperature, pressure, and concentration. So when we mention about standard, okay, so it is known that it should be at this condition. Okay, because any change on temperature, pressure, concentration will definitely affect the E0 cell. Okay, the E0 cell. We don't want that to happen. If we want that to happen, that is another case lah. Kita kena study on the effect of the parameters. Okay, but if we want it to, we just want to know the E0 cell. Okay, that means this condition need to be fixed. Okay, all right. And then, okay, you have learned also about She. She stands for standard hydrogen electrode. So this is our reference electrode in order to measure the electrode potential of other electrode. Okay, all right. So we use She. So She, the standard potential for She is fixed at 0 volt. Okay, if this standard potential for She is 0, that means we can measure other electrodes, other metals electrode potential. Okay, so it's actually with reference to She. If we change the She, okay, we change the standard electrode to something else, that means the electrode potential will also be different. Okay, make sure that if you are asked to draw the She, you know how to draw it. Okay, you will be using the electrode, the inert electrode, which is a platinum. Okay, and then you need to have this like test tube. Okay, the inverted test tube immersed into the solution, and then you have the inlet and also outlet. Okay, the solution should be H+. So normally we would use HCl or H2SO4, 1 molar of HCl or 0.5 molar of H2SO4. Okay, all right. This is an example how the electrode potential is measured for zinc. Okay, so we reference the electrode, the She is used. So we know that She is 0. So this 0.76 can be represented as the electrode potential of zinc. Okay, and then you have also learned about standard reduction potential. Okay, we have a list. We have a list of species or metals. Okay, in a table where you can refer the values. Okay, and the values stand for SRP values. Okay, all right. So one thing that you should should be aware of, that you should know. Okay, so the characteristic of the SRP itself. So when the value is very positive, okay, the value is, that means it has higher tendency to undergo reduction. Okay, so it has higher tendency to undergo reduction, therefore it will be a good oxidizing agent. Okay, and if the value is more negative, okay, a negative value of E0 reduction, okay, it shows that the species prefers ataupun has higher tendency to undergo oxidation rather than reduction. That means it is a good reducing agent. Okay, right. So these are the lists that I have mentioned to you just now. Standard reduction potential. Okay, why is it called reduction? Because they are all measured in terms of the tendency to be reduced. Okay, as you can see, the equations are all in reduction form. Okay, so as you can see, the more negative it is, the higher tendency it is actually to undergo oxidation and not prefer to undergo reduction. So yang atas ni you can see dia negative values kan, maksudnya dia prefers to undergo oxidation. Like lithium plus accepting electron becoming lithium. Lithium plus does not prefer to become lithium solid. I mean, rather than reduce to become lithium, it rather stay this way ataupun to become lithium plus. So that's why the value is negative, very negative. In fact, the most negative species we have in this SRP table. Okay, like I said just now, the more positive the value, the higher it is to undergo reduction. So as we go down the table, you can see that the value become more positive. Okay, all right. So make sure that you also able to relate. Okay, in terms of the value, okay, from the value, it is positive. That means it prefers reduction and must relate with whether it is a good reducing agent or oxidizing agent. Okay. Okay, so we also have learned about strength of oxidizing and reducing agent. Okay, all right. So in an equation, in an equation, we actually have oxidizing agent and also reducing agent, guys. Okay, all right. So in this case, example, zinc 2 plus. Okay, zinc 2 plus can only undergo reduction. Okay, zinc 2 plus can only undergo reduction. Mana ada zinc buang lagi 2 elektron jadi zinc 4 plus. Dia tak akan buang elektron dah zinc 2 plus ni. Dia hanya akan boleh reduce. So kalau dia reduce, it is an oxidizing agent. How about zinc? Okay, zinc solid. Zinc solid can only undergo oxidation. Zinc solid cannot undergo reduction. Kalau dia undergo reduction, can you imagine zinc plus electron become zinc 2e, zinc 2 minus. Do we have zinc 2 minus? Okay, so it is very unlikely, especially at normal condition, at standard condition just now. It is very unlikely. Okay, zinc, I'm talking about zinc solid. Okay, you have to refer the type of species given to you. So if you're given zinc 2 plus, it's actually the oxidizing agent because zinc 2 plus can only undergo reduction. But zinc atom, okay, can only undergo oxidation. They buang electron, they becoming zinc 2 plus. Okay, all right. So which one is since we have these two in an equation, but which one is a better oxidizing agent? Is zinc a better oxidizing agent or better reducing agent? Okay, kita tak tahu dia prefer yang mana sebenarnya. Okay, we are going to be based on the value negative 0.76. Okay, alright. So just now yang kita dah remember yang saya kata you have to take note on this one. Okay, if the more positive the value, that means it shows that it is a good ataupun stronger oxidizing agent. Okay, and the negative the value, the stronger the reducing agent. So with respect to this one, what is given to us, negative 0.76, it shows that, okay, it shows that the negative value, value dia negative kat sini. Negative 0.76. Maksudnya menunjukkan, okay, that zinc is a good reducing agent. Okay, sebab the value is negative. So bila negative value, it shows that it prefers, okay, prefers oxidation rather than reduction. So we could say that zinc is a good reducing agent rather than oxidizing agent. Okay, very weak lah. Kalau zinc ni strong oxidizing agent, or strong reducing agent, that means zinc 2+ will be weak oxidizing agent. Macam you belajar acid base, okay, kalau dia dah strong acid, that means the conjugate will be weak. Dia kena balance. Tak boleh dua-dua kuat. Okay, alright. Okay, so we could say that as we go up the table, okay, as we go up the table, we know that this species prefers oxidation, kan? That means they are, okay, as we go up, they are a good ataupun stronger reducing agent ataupun has higher tendency to oxidize. But how about in terms of oxidizing agent? They are weaker oxidizing agent. We can talk about reducing agent and oxidizing agent at the same time. If it is a strong reducing agent, that means the oxidizing agent will be weaker. The oxidizing agent ataupun strength dia ataupun kebolehan dia, the tendency will be weaker. Okay, right. Moving on. Okay, so this example we have done it. We have discussed about this one. But this one, checkpoint 4. Okay, I have asked everybody to complete this checkpoint on your own, and we will discuss it today. Okay, so please check your answer with the one that we have in the slides. Okay, all right. So arrange based on what you have what you have understood earlier. Okay, arrange the following species in order of increasing oxidizing agent strength and reducing agent strength. Okay, the question 1, you to arrange, okay, based on increasing order of oxidizing agent strength and also reducing agent strength. Okay, you have to arrange for both lah. Okay, let's go for oxidizing agent. Apa ni tu? Okay, dia suruh oxidizing agent. Okay, alright. So we have increasing oxidizing agent. Okay, so let's go for A first. Okay, alright. Oxidizing agent. That means it prefers reduction. Okay, oxidizing agent means dia oxidizekan others, but they themselves undergoes reduction. Okay, so you can identify yang mana yang tend to undergoes reduction. Okay, reduction maksudnya accepts electron. Okay, so we have this part. Ni, zinc 2+, iron 3+, CD 2+. Not this one. Okay, siapa yang jawab zinc, Fe 2+ or CD, you guys got it wrong. Salah. Walaupun arrangement dia tu betul, tapi you tak represent it well. Okay, because these three species won't undergoes reduction. Yang ni saja yang akan undergoes reduction. Nampak? Dia boleh accept electron to become zinc. Okay, kalau ini accept electron jadi apa? Jadi zinc 2-. Ada ke zinc 2-? Ada? Mana ada? Okay, iron 2+, maybe boleh jadi ni, tapi iron 2+, this is either iron 2+ to iron 3+, kan? Iron 3+ to iron 2+, kan? Ni iron 2+, kalau accept electron jadi iron plus. Okay, very unlikely. Okay, same goes to cadmium. Okay, so these are the 3 species that you need to arrange okay, in terms of increasing oxidizing strength. Okay, so how do we arrange? We are going to be based on the value given to us as is. Do not change anything. Okay, alright. We are talking about oxidizing agent kan, yang undergoes reduction. That means the more positive the value is, that means the higher tendency is to undergo reduction. Therefore, the stronger the oxidizing agent. So kita kena arrange. Siapa yang paling positive value dia? Okay, this one number 1 paling positif. That means dia punya the strongest lah, the oxidizing agent, the oxidizing strength is the strongest, followed by this one, number 2 and number 3. Okay, so how do you arrange them? So you should increasing from the starting from the smallest to the largest lah, to the highest. Okay, so we would have Fe3 plus, okay, and then Cd2 plus, followed by Zinc 2 plus. Okay, so this is in terms of oxidizing strength. Okay, ada tajuk sikit kat atas tu. Okay, now let's arrange based on reducing strength. Okay, right. Let's arrange the species in terms of reducing strength. So these are the 3 species that can undergo oxidation, because we are talking about reducing strength, reducing agent strength. That means they themselves will undergo oxidation. Okay, all right. So which of these 3 is the strongest oxidizing agent ataupun tend to undergo oxidation? So we are going to be based on the same values. It's just that now, since that undergoes oxidation, apa dua dia tadi reduction kena more positif, betul tak? Sekarang oxidation dia kena more negative. You kena ingat dua tu je. Okay, alright. So kalau oxidation, kalau dia prefers to undergo oxidation, that means the more negative the value is, the higher tendency it is to undergo oxidation. Okay, so kita check yang mana yang paling negatif. Okay, zinc. This will be number 1, followed by number 2, number 3. It should be the opposite lah. Should be the opposite. Okay, alright. So in terms of reducing strength, okay, so it would be dia paling weakest kan, paling weakest to the strongest. Weakest tadi siapa? Number 3, iron 2 plus. Okay, and then Cd solid, and then lastly we have zinc. Okay, sama tak jawapan dengan saya punya? You guys, you get the same answer as mine? Ke macam tersalah faham lagi? Sekarang baru faham, madam. Ke macam mana? Sama tak?
Sama.
Okay, sama, bagus. Okay, jangan terpening-pening kat sini . Ada juga student yang memang common lah, student terpening-pening. Macam mana nak determine dia mungkin dia pandai arrange tapi dia salah pakai species. You salah pakai species, salah. Okay, alright. So that's basically how you should arrange in terms of strength of oxidizing agent dengan reducing agent. Okay. Nah, so ni jawapan yang number 2 lah. Okay, nampak dia punya spesies tu sama tapi lain. Ini dalam keadaan molekul. This is atom, Y, ini ion, this is atom. It's not the same. Y tu sama lah, but this is ion. This is atom. Okay, alright, moving on. Okay, so now we are going to start ataupun we are going to start the calculation part. Okay, we are going to learn on how to calculate the standard cell potential, or in short, it can be written as E naught cell. E stand for cell. E stand for potential. Naught stand for standard condition. At standard condition, cell means the potential of the cell. Okay, all right. So the formula to calculate E naught cell or EMF is given below. So E naught cell depends on the composition of the electrodes, the concentration of the ion in the half cell, and the temperature and pressure, okay, of the cell. So if any of these three, okay, is changed, that means it will definitely affect the E naught cell. Okay, all right. So a positive E naught cell, let's say we have okay, this is the formula, the first formula. Okay, it's very simple. It's tolak saja, just subtraction, the product of subtraction between cathode minus anode. That means you have a cell, katakanlah you are given a cell, you have to identify which will undergo reduction and become cathode and which will undergo oxidation and become anode. That is all. And then you take the value, insert into the formula, okay, and then you can simply calculate for E naught cell. Okay, alright. When you calculate E naught cell, very simple, just tolak je. Value pun boleh dapat daripada SRP table just now. Okay, you can simply take the value ataupun insert the value, extract the value from the SRP table, okay, right away. So because this is actually in reduction form, okay, which is the same as what we have in the SRP punya table, okay. All right, so if you got the E naught cell value positive, so it indicates that the reaction is a spontaneous reaction. Okay, the reaction is a spontaneous reaction. I mean, it will happen naturally lah. It will the flow of electron ataupun the reaction will take place spontaneously ataupun naturally. Okay, naturally maksudnya dia just based on the different in electrode potential. And then if they sense the different in electrode potential, dia akan flow. Okay, so these are the standard condition for the cell. The partial pressure need to be 1 atm, temperature need to be 25 degrees Celsius, and concentration need to be 1 molar. Okay, this is very important, guys, because later on we have a non-standard electrode potential. This one is standard electrode potential. Next, we will have non-standard electrode potential, which we will vary the concentration. It's no longer 1 molar. Okay, it's no longer 1 molar. All right. That's the formula, the first formula. We have 2 formula je so far. Senang je untuk this electrochemistry punya topic. Okay, untuk calculation dia, it's actually very simple. And then it only involves two formulas. Okay, all right. So let's look at an example. Calculating cell potential under standard conditions. Calculate the standard cell potential of the following voltaic cell at 25 degrees Celsius using standard electrode potential. Okay, so this standard electrode potential SRP lah. From the SRP, you can also refer from SRP, but it's already given to you. In exam, definitely we will not be going to give you the SRP punya table. Okay, instead we are going to list out lah the species involved in the cell. So like this, macam ni Okay, so we have aluminium and iron 2+. And you have aluminium and also iron. So this is the voltaic cell punya cell notation. Okay, and there's a lot of information that we can gain from this cell notation. We know who will undergo oxidation, therefore we also know we have the information who will be undergoing the reduction. Kalau dah tahu oxidation siapa, reduction siapa, definitely we will know the who will become the cathode, who will become the anode. Okay, alright. So from the value, let's start from the value lah. Katalah it's not given to us. This cell notation is not given to us. So we need to use the value. Okay, from this one. Okay, let's just write. Dia suruh apa? Standard electrode potential kan? E tulis dulu, takut lupa. E cell is equal to E naught cathode. Okay, jangan terbalik. Minus E naught anode. Okay, so we have to identify cathode. That means the one that undergoes reduction. This one, the one that undergoes oxidation. Okay, but bila you nak extract value tu, ambil as is dalam bentuk standard reduction potential. You don't have to change into oxidation. Tak perlu. Okay, if you are using this formula, you are going to use the SRP value directly. There's one formula, lagi satu, tapi we have already, remove it from our syllabus. Sebab kadang-kadang student ni confused lah, okay? Because that one, the other formula tu you have to change. Okay, if it undergoes oxidation, the value is negative, you have to change into positive. Okay, so that one has been removed from the syllabus. So we are just going to be based on the value from the table SRP in the form of reduction. Okay, alright. So kita dah identify. Okay, so what we have learned just now, the more negative the value is, the higher tendency to undergo oxidation. Okay, between these two, yang mana yang more negative? This one, negative 1.66. Therefore, aluminium will become the anode. Yang ni kan less negative kan? So, this one will become the cathode. So, once you have identified this one, masuk je lah dalam formula ni. Okay, you can also use this, since it is given, you can double confirm. As you can see, nampak aluminium is located on the left hand side. Left hand side is the oxidation part. Right hand side is the reduction part. Okay, so dia tally lah. Value wise pun ni, cell notation pun align. Okay, so you can just simply take the value, ambil sebiji, tapi make sure betul ya, value tu kena ambil. So negative 0.41, see, minus 1.66. So as you can see, so the value is positive value. So this is what we call spontaneous reaction, guys. Spontaneous reaction. If you got negative value, that means it is a non-spontaneous reaction. Maksudnya, it will not happen naturally. Okay, dia akan terjadi the other way around. Kalau negative value, it shows that, it indicates that the reaction is not spontaneous. Maksudnya, kalau macam tu, it will not happen as is. Okay, tapi dia terjadi the other way around. Sebab dia non-spontaneous kan? Cuba try checkpoint 5, guys. Okay, try out this checkpoint 5. Okay, I give you like 3 minutes for you to complete this checkpoint. Kita discuss kejap lagi. Right, so how is it? Are you done?
Yes, madam.
Yes, madam.
Yes, madam.
Yes,
madam.
madam. Yes.
Right, very good. Okay, so let's go through the question. Given the equation, this is the full equation. Okay, this is the full equation, and then the E naught cell for this reaction is this one. This is the E naught cell. Okay, you guys please make sure that you know how to differentiate between E naught cathode, E naught anode, E naught cell, E naught reduction. Okay, so when we are talking about E naught cell, that means these values is referring to the cell. Okay, so in the cell we should have 2 electrodes, 2 half cell and whatnot. So this value is actually the value of the cell. Okay, bukannya yang ni, bukan this one, not this one. Okay, banyak-banyak value nanti confuse. Okay, the standard reduction potential for CO2 plus is this. Okay, for CO, standard reduction potential for CO2 plus is negative 0.28 volt. Determine the standard reduction potential for Ce4 plus to Ce3 plus. Okay, it's the same thing. You still need to be using the simple formula just now. The E naught cell is equal to E naught cathode minus E naught anode. Okay, all right, so this one has been given to us 1.89 volt, but we have to determine the standard reduction potential for Ce4 plus to Ce3 plus. But first step is to identify which of these species, okay, will undergo oxidation. Siapa yang undergoes reduction. That's why we have this equation. Okay, from the full reaction equation, we can determine which one is the cathode and which one is the anode. Then only kita tak tahu yang ni, dia dah bagi dah, tapi kita tak tahu whether nak place dekat cathode or anode. So kita kena confirm this one first. Okay, from the equation, it shows that CO2 plus. Okay, look at the CO. So CO becoming CO2 plus. So this is oxidation characteristic, right? CO 0 and then becoming 2 plus. The charge ataupun the oxidation state is now positive 2. So it is increased. Okay, so that is a characteristic of oxidation. Therefore, CO, this one yang dibagi ni, standard reduction potential for CO2 plus, okay, is for anode. Okay, so dia jangan confuse kenapa dia bagi CO2 plus dan madam kenapa dia tak bagi CO. Okay, sebab dia tengah ceritakan, dah cakap tadi reduction. Kalau CO dia bukan reduction, CO dia oxidation. That's why dia standardizekan dekat table tu semua dia bagi dalam bentuk reduction. So dia betul CO2 plus. Tapi bila kita nak masuk dalam equation ni, not to worry, we can just simply take the value. Tapi kita kena take note that what actually happen in the reaction is that CO change to CO2 plus. Tapi value wise kita akan ambil daripada ion tu sebab dia undergoes reduction kan. Semua dalam SRP tu kan undergoes reduction. Semua starting dia adalah yang especially yang dekat bahagian atas tu ions. Pasal tak? Okay. Alright, so once you have determined this is the anode, so and then you dah cakap standard reduction potential kan. So negative 0.28 volt. So ini E naught cathode. Alamak, apa masalah ni? Carilah, tekan je lah calculator. Okay, alright, so what's the value? 1.61 volt. Okay. This kalau macam ni lebih nampak pun. Okay, ini daripada kalau reduction potential kita rupa dia macam ni. But what we need is the value. Kita just nak determine, kita nak this value to be inserted into the formula. Okay, but formula ni kena pakai formula reduction. Ni nampak ni. That's why dia tulis red kan so. Dalam bentuk reduction form. Okay. Okay, spontaneity of redox reaction under standard condition. Okay, the spontaneity of the reaction. We have talked about this actually just now, tapi this is in detail. Okay, we have a slide for the spontaneity of the reaction. Okay, like I've said, like what we have earlier, the value, if the E naught cell value is positive, it shows that, ataupun it indicates that the reaction is spontaneous. And if it's negative, it shows that the reaction is not spontaneous. Okay? Okay. Spontaneity of reaction can be determined by looking at the cell potential, the one that we have calculated just now, the E naught cell. Okay, so positive cell potential indicates the redox reaction is spontaneous, while negative cell potential indicates that it is non-spontaneous. Okay, all right. Okay, so example. Okay, so these are the two SRP values given to us. Okay, all right. So how do we get spontaneous reaction? Bila kita follow dia punya syarat dia tu lah. The more positive the value, yang akan undergoes reduction. The negative the value will tend to undergoes oxidation. Kalau follow yang itu, dia akan spontaneous. Kalau dia tak follow yang itu, dia terjadi the other way around, it will become non-spontaneous. Okay, alright. So based on the equation, based on the SRP value here, you could say that this will tend to undergo oxidation, right? Ataupun will become the anode. This will undergo reduction because the value is positive. Okay, just ingat dua tu je. Kalau nak undergo oxidation, dia punya value berapa? Bukan value berapa, dia punya value tu should be more negative. Kalau nak oxidation, okay. Kalau reduction, the value, kalau dia prefers reduction, that means the value should be more positive. That is how we chose our cathode and anode. Okay, alright. So if they follow dia punya rules just now, this is the equation, the equation that take place and produce a spontaneous reaction. Zinc becoming zinc 2+, copper 2+, accepts electron becoming copper solid. And when you try to calculate the E naught cell, you will get a positive value based on this equation. Okay, all right. If the reaction is conducted the other way around ataupun the opposite way of this one, opposite maksudnya apa? Tadi zinc yang akan oxidize kan, ni dia terbalik. Copper jadi copper 2+. See, dia oxidize. Zinc 2+ jadi zinc. Based on this equation, katakanlah dia bagi this equation, dia suruh you determine whether this reaction is spontaneous or non-spontaneous. Okay, so kita nak check, kita check. Okay, kalau based on this equation, copper oxidize kepada copper 2+. Tapi bila kita tengok value yang dia bagi, this is opposite to the values given. Okay, so kita boleh predict that it is non-spontaneous already. Cuba you prove kan, you calculate the E naught cell, see, you will get a negative value. Sebab dia dah totally terbalik. Copper sekarang dah jadi anode. Zinc dah jadi cathode. So bila you masukkan dalam this equation, of course lah dia akan produce the same value, tapi the sign is now negative. So this indicates that the reaction is non-spontaneous. Okay? Okay, cuba buat check point 6. Okay, you have to calculate the E naught cell value, the EMF value, and state whether the reaction to occur spontaneously in forward reaction. Maksudnya you have to check for this reaction, you don't have to change anything, you kena check whether dia spontaneous or non-spontaneous. Kalau you get negative values, that means it is non-spontaneous. You dapat positive value, it is a spontaneous reaction. Okay, just simply based on the reaction. Yang ni nickel jadi nickel 2+, so it will become nickel becoming nickel 2+. This is anode lah kalau based on this reaction. deoxidation kan. Zinc 2 plus becoming zinc. So this is reduction kan. So it will become cathode. So insert into the formula, then calculate. Do you get positive or negative value? Okay, so nak cari values, pergi cari daripada SRP punya table. Cari sendiri lah. Okay, alright, so try to calculate A, B, and C, and then we will discuss it in a bit. Okay, so I give you like 3 minutes lah sama. Okay, alright, cuba buat. Ada question? If you have question, please do ask, okay? Right. Okay, dah. Dah ke, guys?
Dah.
Okay, the rest.
Dah,
Dah
madam.
ya?
Dah.
Dah, madam.
Right. Okay. Jom kita check jawapan ya. Ni kena refer from SRP table for you to get the values and then insert into the formula. Tapi saya tahu A ni non-spontaneous. Betul ke? Sebab zinc ni dengan nickel. Zinc is more likely to be oxidized rather than nickel. Saya tahu A lah sebab zinc kan kita familiar kan. Lead dengan nickel tak familiar. Lead dengan aluminium. C spontaneous sebab aluminium is considered as, maksudnya ranking keoksidasian dia tu. Okay, tinggi juga. Cuba cek. See? Okay, so A non-spontaneous. Value. Make sure you get the same value as what we have in the slide. Okay, so kita confirmkan. Okay, confirmkan values from the SRP. Okay, make sure that you get the same values for the Naught cell. Okay, so these are the answer. Maksudnya negative 0.53 volt non-spontaneous in forward reaction. Maksudnya forward reaction dia non-spontaneous. Tapi kalau kita terbalikkan, I mean nickel undergoes reduction, zinc 2+, nickel undergoes reduction, zinc undergoes oxidation. Okay, then it will become spontaneous. That's why dia kata, if this is the case, okay, it won't be spontaneous. It will become non-spontaneous. Okay, in forward reaction. Maksudnya kita follow as is. Right? Okay. So these are the answers. Okay, guys. Moving on to the next subtopic, which is non-standard potential. So by right, this week, guys, we have to finish this topic by this week. So next week, we shall start with topic 5. Our very last topic of the semester, topic 5, one of the killer topic. So please be prepared, okay, for topic 5. Okay, so kita kena habiskanlah topic 4 ni by this week. Okay, non-standard cell potential. I believe this is the second last subtopic in topic 4. Okay, alright. Just now we have standard cell potential, kan? Now we have non-standard cell potential. That means the condition is no longer at standard condition. That means one of the standard condition is changed to something else. But normally for our syllabus, our target is more on the concentration. For standard condition, the concentration will be at 1 molar. But for non-standard, other than 1 molar. It can be more than 1 molar. It can also be less than 1 molar. Okay, so as long as it is no longer 1 molar, it is considered as non-standard cell potential. Okay, all right, so we have a calculation for this one. We have a formula for this one. Again, we have to calculate each cell. As you can see, we no longer have this Naught there. See, because it's not at standard condition anymore. So we don't have the Naught there. The Naught represent standard. Okay, so the formula that we are going to be using is the Nernst equation ataupun Nernst formula. Okay, this is your second formula of topic 4. That's all, and then we are done. Settle dah. Tak ada formula lain dah. Okay. The effect of concentration on the EMF of the cell on the cell potential lah. On the cell potential, okay? When the concentration of electrolyte, pressure, pH, and temperature change, if any of these four, okay, is changed during the course of reaction, the conditions are no longer as standard. Thus, the cell potential will also change, like I said just now. Okay, so the effect of concentration on the cell potential of a cell. So our focus is more on the concentration lah. Okay, we do not study the effect on pressure, pH, and temperature, but instead our focus is more on the concentration. Okay, all right. So it is possible to get a spontaneous reaction when the oxidation and reduction reactions are the same, as long as the electrolyte concentration are different. Okay, so what does it mean by this statement? Mula-mula saya tak faham Bila saya tengok the next slide, then baru I get it. Okay. It is possible to get a spontaneous reaction when the oxidation and reduction reaction are the same. Ni tak faham. Are the same. Maksudnya, it is referring to the same ions ataupun the same species in the solution. Normally, we would have zinc and then copper. Okay, alright. Itu maksudnya the ion solutions are different. Okay, but what it meant by this statement adalah bila in one cell it is copper, the other cell is also copper. Itu maksudnya reaction are the same. Okay, so the reaction can still be spontaneous as long as the concentration are different. Okay, the concentration are different. So, okay, you boleh imagine tak? Okay, normally yang galvanic cell previously, we would have different species kan, different ions lah. For example, zinc dengan copper, and the way that the electron flow is that based on the different in potential, electrode potential kan, based on that. Okay, tapi kalau kita ada copper and copper, dua-dua copper, by right, there should be no different in potential, betul tak? Kalau dah copper, benda yang sama, so by right, there's no different in potential. Bila ada different in potential, baru dia bergerak. Now, copper, there's no different in potential. Okay, memang dia tidak akan bergerak kalau both of them are having the same concentration. Solution concentration. Maksudnya 1 molar. Okay. That one, it will be 0 because there's no different in potential. Tapi macam mana kita nak bagi dia flow juga? Kita nak the electron flow from one side to the other side. Ada satu cara. We have to vary the concentration. Okay, we have to vary the concentration. Okay, we will look into that later in a bit. For same electrolyte, okay, that means it has the same electrolyte, like I've said just now. Electron will flow from anode, okay, which is the less concentrated solution, to cathode, which have the more concentrated solution. So tadi dah cakap kan, as long as dia punya concentration berbeza, dia punya electrode dia sama tak apa. Okay, silver, tak apa. Dia punya solution punya concentration should be different. So kalau they have different in concentration, that means one of the solution should be more concentrated than the other. Ataupun one of the solution should be less concentrated than the other. Okay, so dia punya konsep dia adalah the electron will flow, okay, from the less concentrated to the more concentrated. That means the less concentrated, the electrode immersed in the less concentrated solution will become the anode. Okay, this one. Yang more concentrated solution, okay, the electrode immersed, the electrode will be the cathode. Macam ni lah. Contoh, like I said just now, okay? Alright, so we have this cell. On anode, for anode we have copper as the electrode. For cathode also we have copper. And the solution, both of the solution is also copper 2 plus, and they both have the same concentration. For this one, when the cell concentration are equal, there is no difference in energy between the half cell. No difference in potential lah, senang cerita. Okay, so kalau tak ada difference in potential, kenapa elektron tu nak kena bergerak? In the first place, dia stay je lah. The reason dia bergerak adalah dia sense, okay, kawasan ni is more positive. Kawasan ni is more negative. Therefore, the electron need to be moving to the side that is more positive. Sebab elektron kan negatif kan? So they sense dekat sini more positive. So the electron will be moving from is negative to the positive. Habis kalau dah sama, dia nak sense apa? Dia tak ada that difference. Okay, so dia stay lah. So there will be no electron flow. So in order to have in order for the electron to flow, okay, the cell concentration need to be different. Like this is the first one kan, this is the second one. So exactly the same. The setting is exactly the same. The electrode and salt bridge, the solution is just that the concentration is not the same. They both have this different in concentration. So we have one on the left hand side is 0.01 molar. On the right hand side we have 2 molar. Okay, very concentrated, and we can observe in terms of the color intensity of the solution. On the left hand side, nampak tak? They become lighter blue. On the right hand side punya half cell, it is more bluish, ataupun the intensity of the color is more bluish lah, okay, more intense. Okay, so the electron will flow from the side with the less concentrated, which is from the anode. They always from the anode to the cathode. Okay, it will always from the anode to the cathode. Sebab anode is where the oxidation takes place, where the electron is produced, where the electron is being removed. Okay, alright. So that's why less concentrated akan duduk dekat anode, to the side with the more concentrated solution, cathode. Okay, less to more. Cik benar dia punya ni. So what actually happened is that, let me just make it bigger. Okay, kejap ya. Copy. Lah. Skip. Okay, alright. Okay, so this is the less concentrated and concentrated solution on the right hand side, ataupun where the cathode is placed, is the more concentrated solution. Okay, right. So what actually happens is that benda yang sama, konsep yang sama. Okay, so bila ada different in concentration, there will be different in potential as well. But not because of the electrode, the different in electrode, is because of the different in different potential due to the concentration difference. Yang kita belajar sebelum ni, yang zinc dengan copper, electrode tu sendiri ataupun the ion itself produce, the ion itself have different in potential. Tapi this one, ionnya sama. Okay, tapi wujud juga different in potential due to different in concentration. Okay, alright. So what actually happen is that kenapa dekat sini less concentrated, guys? Kenapa dekat sini mesti less concentrated dekat anode? Dekat cathode must we must place the what do we call that, more concentrated. Okay, alright, so macam biasa, bila wujudnya different in concentration, wujudlah different in potential. So what happen is that so this one, okay, the copper from the electrode just sends dekat sini less negative, less positive lah. Sebab as you can see, the concentration is 0.01 molar. That means we have less copper 2 plus in this half cell. And we have more copper 2 plus ion in this half cell dekat kanan ni. Okay, alright. So bila dia itu adalah different potential. So what happens that the copper macam biasa, copper solid from the electrode, okay, will jump into the solution producing copper 2 plus and leaving behind the electron on the electrode. Okay, sebab dia sense ni kurang positif ni kat sini sebab dia kan less concentrated, kurang copper 2 plus ion. So the copper atom will jump into the solution becoming copper 2 plus to add more copper 2 plus ion and leaving behind the electron. So this electron will be flowing through the external wire. Okay, dia akan flow from anode to cathode and electron, and this one will be accepted by copper 2 plus. So bila copper 2 plus accepts the electron, it will become copper atom. So it will get deposited on the electrode. It will get deposited on the electrode. Okay, so after a while, bila dah lama-lama kan dia jump into the solution kan, so it will increase up the amount ataupun the number of copper 2 plus ion in this solution, and this one will decrease. So you akan observe after a while this solution will become bluish, more bluish. Macam mana bluish blue, easy this one. Okay, jadi lagi intense lah the color, and this one will become less bluish. Macam mana macam itulah bluish, kurang biru. Okay, sebab dah banyak jump into the solution. So this is what happened. Copper, it oxidized becoming copper 2 plus and producing electron. Okay, and this is what happened on the reduction half cell. Copper 2 plus will accept the electron and becoming copper ion. Okay, after a while, it will become less concentrated. Yang kat sini pula akan jadi more concentrated. Okay. So, macam mana nak buat equation guys? Sebab copper kan. So, for this case, you kena specify the concentration. Barulah you boleh tahu ni datang daripada mana ni. Copper 2 plus ni ion kan. So, ion should have concentration. Okay, so copper 2 plus for the first one, sebab you gather, you kumpulkan this is oxidation kan. This is reduction. Macam biasa, you total up these two equation, you will produce this one. You akan produce this one, this equation. Tapi how do we differentiate this copper 2 plus dengan this copper 2 plus? Okay, so itu yang kita assign dia punya concentration ni. This one. This one, this copper 2 plus as the product come from the oxidation. Ni. Kan dia duduk lepas arrow kan, so it will be the product of oxidation. So kalau duduk lepas reaction, lepas arrow, okay, so the copper 2 plus come from the oxidation punya product. And this one copper 2 plus dekat reduction dia duduk dekat sebagai reactant. So this copper 2 plus belongs to reduction cell, reduction half cell. So it will be the 2 molar. Okay, jangan just simply, dia kan daripada less concentrated kepada more concentrated, dah come out dengan ni, lepas tu tiba-tiba ini terus buat 0.01, ini 2.0. This is wrong. Okay, this one you kena buat equation from oxidation. You got this one from the total of oxidation reaction plus reduction. Baru you dapat this one. So you cannot just simply assign concentration. Oh, ni kan tadi less concentrated to more concentrated. Therefore this copper 2 plus should be less concentrated. This one should be more. No, tu salah. Okay, itu salah. Okay. Okay, so itu kita dah tahu. Okay, when ion concentration are not 1 molar for different electrolyte. Okay, so what about if we varies the electrode and also the concentration? Okay, this one case dia electrode dia sama, solution dia sama, tapi concentration berbeza. How about this one? Yang normal one, the previous one for galvanic cell. Okay, we have zinc dengan copper. Kita ada different in electrode kan? That one dah create electrode potential, dah create different dah in potential. But not only that, we also varies the concentration, guys. So this is the normal version, the standard version, because the concentration is at 1 molar, for both solution. How about if we have two different electrode and different if we have two different electrode and also different concentration? Okay, so dia set kat sini copper 2 plus has higher concentration at the cathode, zinc 2 plus has less concentration at the anode. Okay, alright, so this one, according to Le Chatelier's principle, the forward reaction has a greater tendency to occur, resulting in a greater overall cell potential than the cell potential under standard condition. Okay, nampak tak dia punya cell potential dia tu? Increasing. When you vary the concentration, it will affect the cell potential. Okay, it will affect the cell potential. So how do we calculate the cell potential for this type of cell? Okay, we are going to be using this equation. So this is what we call Nernst equation. Okay, it is used when the concentration is no longer at 1 molar. Okay, kalau dia still 1 molar, everything is still at standard condition, you are not going to be using this one. You are going to be using the normal one, the simple equation. Okay, the E cell is E naught cell is equal to E cathode minus E naught anode. Okay. Okay, the quantitative relationship between electrode potential and concentration of aqueous ion as well as temperature is given by the Nernst equation. Okay, hafal and make sure before you proceed with calculation, you have this equation first. If anything happened during your substitution in your working solution, at least, okay, you will be given mark for your equation. Okay, guys. All right. So this is the formula. You can memorize E cell. Tapi yang menariknya dalam E cell ada E naught cell. E naught cell ingat yang kita dah buat tadi. E naught cell formula dia is E naught cathode minus E naught anode. Ada juga. Okay. Ni. This one. This is the formula. Okay. 0.0592 over N. N, familiar tak N tu apa? Number of mole of electron. Log ada. Q, remember Q? Quotient, reaction quotient. Product over reactant. Okay? Bagusnya you dah belajar before this kan? Okay. So Q basically the concentration of product over concentration of reactant. We can also simplify in the form of normally the concentration of product come from the oxidized form and then the reactant come from the reduced form. Macam biasa, jangan include yang solid, jangan include yang liquid, kita include yang ion sahaja. Okay? So reaction quotient using molar concentration for ions macam biasa, we will be using the concentration lah. Okay, and partial pressure for gas. So what we have learned in our topic 2 last time, we have QC and QP, right? For this one, Q, you tahu tak sebenarnya you boleh combine. Okay, tiba-tiba involve gas lah dekat dalam your cell tu ada gas atau hydrogen gas ke apa kan. So it's not given in terms of concentration but it's given in terms of partial pressure. So bila you nak masukkan dalam Q tu, you can actually combine concentration and pressure in the same Q expression. Okay, itu satu benda yang ni, that's why dia bagi note kat situ so maksudnya it can be QC, QP. It can be combined into the same Q expression. Okay. Dan nanti janganlah terkejut. So maksudnya bila you buat macam ni, contoh lah kan. Q is equal to product over reactant. Tiba-tiba katakanlah atas ni semua dalam bentuk concentration. Okay, tiba-tiba bawah tu boleh dalam bentuk pressure. Katakanlah dia bagi 1 ATM ataupun 0.1 ATM. Yes, you can combine atas concentration, bawah partial pressure ataupun the partial pressure can be included into the same expression. Atas ke bawah ke dia boleh bercampur sekali. Boleh Right. Okay, so this is the equation. Okay, let's just write here. E cell. Okay, we don't have the Naught there because this is non-standard cell potential. We have E Naught cell tolak 0.592 over N. N is the number of electron. Macam mana nak dapat N, madam? Bila you nak buat final equation yang you kena cancel out the electron tu, dekat situlah kita tahu N tu berapa. Okay, nampak macam mudah tapi sebenarnya banyak kerja to be inserted into this formula. There's a lot of things that you have to consider. Satu, E Naught cell. Satu lagi N. N dapat dari mana? Daripada when you combine the reduction and oxidation equation. And you kena cancel out you kena make sure that the number of electrons should be the same, right? So that it can be cancelled out. Okay, itulah N awak, number of electron yang cancel tu. Log, it should be log bukan ln Q. Okay, so we are going to play around with this value dekat sini. You kena imagine lah. When Q is less than 1, how do you get Q? Ada three conditions that you have to consider. Okay, if we have Q less than 1, how do you get Q less than 1? Remember, Q is product over reactant. So in order to get less than 1, this value should be higher. Betul tak? So the concentration of reactant should be higher, will be higher than the concentration of product. Then only you get Q less than 1. Then how about if you logkan the Q? Ni log ke ln Okay, how about if you logkan the Q? Ni ganti log lah ni. Okay, you logkan the Q. Please ganti log guys. Okay, you logkan the Q. You logkan the Q. Then what will be the value? So the value will be less than 0. Cuba tekan calculator, boleh compare lah kalau nak try ni kan. Log Q, ini dah dapat less than 1 kan. So the log Q, this one. Bila you logkan value yang kecil, small value, katakanlah this one. Respect to this one small value, Allahu Akbar. What happen if you logkan small value? Okay, the value will also be less than 0. That means it will be more negative lah. It will become negative. So that it will become negative value. So that less than 0. Okay, so what will happen to the E cell guys in comparison to E Naught cell? If you get this value, negative value, dekat sini you dapat negative value here, you dapat negative value. So negative dengan negative dekat sini, ingat, betul tak? Ini you dapat negative values because of this one statement dia. Ini don't lupa we have a subtraction operation there. Negative will produce positive value, right? So produce positive value and then plus with E Naught cell. Okay. Therefore, the value will become, the E cell will be larger than E naught cell. That's the conclusion of it. Okay, that's the conclusion of it. So boleh play around lah. What if the Q is equal to 1? That means the concentration of reactant and product is almost the same, and the value will be the value of log Q. When you log the Q, when you log 1 lah, you log 1, you log 1, you get 0. So at the end of the day, this value you akan dapat kosong. Betul tak? Sebab you times dengan kosong, kan ni operasi darab kan? So E cell is equal to E naught cell. Okay, and what if the Q is more than 1? That means concentration of reactant is lower ataupun the concentration of product is high. Okay, when you logkan the large value of Q, you will get the value here, the log Q value will get positive value. More than 0 kan? Positif lah. This one less than 0 kan? Positif. So bila you dapat positive value, don't forget you akan darab dengan this one, and this one kat depan ni tolak. You dapat positive value kan? So you akan positif dengan negatif, you akan dapat negative value. So it's like E naught cell minus something. Okay, minus something. So definitely you punya value of E cell, bila you kena tolak something, okay, will be less than E naught cell. But you tolak dengan E naught cell ni, so value of your E cell will be less than E naught cell. Soalan ni famous keluar dekat objektif. Weak structure pun pernah keluar. Okay, kalau keluar dekat objektif, bahaya, 2 markah. Kalau keluar dekat structure, 1 to 2 marks jugalah. Okay, make sure you understand it well. Okay, guys. Okay, right. So let's try out this example. Consider a galvanic cell with identical half cell reaction. Calculate its cell potential. Kecilnya. Okay, you kena identify dulu. You nak pakai, you have to identify whether this is at standard condition or non-standard condition. Okay, if you get this type of question in exam, this is quite obvious lah, because dah tulis kan non-standard condition. So we straight away use the Nernst equation. Tapi kalau nak exam, you identify dulu. Ni standard ke non-standard? Macam mana nak tahu standard? Dia punya concentration should be the same, which should be at 1 molar. Okay, so as you can see, ni tak sama and not at 1 molar of concentration. So Nernst, terus pakai Nernst. Buat equation Nernst siap-siap. Kok lah nanti panik ke apa, at least ada equation tu kan. Dapatlah 1 markah daripada 5. Okay lah, daripada 0. Okay, alright. Prepare the Nernst equation. So this is your Nernst equation. Okay, apa yang nak kena ada? E naught cell. Okay, cari dulu E naught cell. So what's the E naught? What is the E naught cell? So kena buat dulu asing kat luar. Determine which one is the cathode, which is the anode based on the value. Katakanlah dia tak bagi this diagram. Okay, so how do you determine the cathode dengan anode? Again, based on the value given to you. More positive, that means it will become cathode. More negative, it will become anode. Okay. Alright, so when you tolak kan, turns out you dapat 0. Sebab yelah dia pakai ni kan. Dia punya, apa nama tu? Electrode dia, both electrode are copper. Okay. Alright, number of electron guys. Number of electron. So, this one, yang cancel out tu. Kena cancel out Maksudnya, you bukannya kat sini 2, sini 3. Nanti you total 3 tambah 2, 5. Don't do that. Bukan total dia yang kena cancel tu, maksudnya total cancellation tu. Itu yang akan will be inserted into the Nernst equation. Okay, don't just simply 3 tambah 2, 5, masukkan 5. Don't, please guys. Okay, log. Okay, ni nak masuk mana ni? Okay, okay. Nak masuk mana? Tengok equation ni. Sebab kita nak come out dengan Q. Betul tak? Product over reactant. So ni. Produk kita siapa? Copper 2 plus. Ini pun copper 2 plus. This one will not be inserted because they are all solid. Don't include. Copper 2 plus. Okay, masalah pula. Copper 2 plus ni yang mana satu yang berapa dia punya concentration. You kena confirm, right? Okay, you kena check daripada equation. Okay, this is from cathode. That means kalau cathode kat sini, ini yang pekat. Berapa pekat? 2 molar. This is 2 molar. Yang this one daripada anode, betul tak? Anode di copper 2 plus dia adalah 0.01 molar. So bila you dapat dekat sini, this one is 2 molar. This one is, you selesaikan, you totalkan, this one is 0.01 molar. Baru you masukkan P over R. Product over reactant. So you ada copper 2 plus 0.01 molar. Okay, as your nominator, your denominator should be 2 molar. Dah. Boleh selesaikan, tekan saja calculator, then you get your E cell. Okay. Another example, consider a galvanic cell involving the following half reaction, guys. Okay, calculate the cell potential, calculate the cell potential when nickel 2 plus concentration is this and chromium 3 plus is this. So the moment you see the concentration, okay, are not at 1 molar, definitely you will be needing the Nernst equation. You will be using the Nernst equation. Okay, alright, so buatlah equation dia siap-siap, the formula, because from the formula it guides us on what to do next. Kalau saya takkan terus kira ni. Saya akan buat Nernst equation tu dulu sebab dia guide kita. Okay, alright, so buat Nernst equation. Okay, dalam Nernst, buatlah balik E cell. E cell jangan ada note kat sini is equal to E naught cell. 0.592 over N log Q. Okay, alright. Cari E naught cell dulu. E naught cell. Okay, so the values are already given to us. Ini pun kita boleh predict siapa cathode, siapa anode. This one become cathode. This one become anode. Because they're very positive than this one. Okay, alright. So okay, this one you can simply calculate the E naught cell lah. Okay, E naught cell. Okay, you can simply calculate the E naught cell. Okay, next. Kenapa kita kena go through this one, guys? Because what we want next, ini dah settle E naught cell. We can simply use this value. Dah determine kan cathode dengan anode. Next, kita nak cari N. That's why we need this part. Okay, alright. So we have to the one that undergoes oxidation. This is the equation. This is oxidation. This is reduction. You kena buat begini. Okay, and then from the equation, as you can see, they both have different electron. Okay, they accept and remove different number of electron. So here is the part where you have to multiply with a factor. Okay, you have to multiply with a factor ataupun an integer so that they will produce the same number of electrons. So in this case, sini kena darab 2, sini kena darab 3. Everything need to be multiplied by the factor, a sign. Okay, so you akan dapat this one. This is very important, okay guys. Ni dia punya coefficient ni penting ya. Sebab ingat yang QU tu, product over reactant, yang you kena kuasakan tu, kena ya, ada kuasa-kuasa kat sini M dengan N ke apa benda tu. Ya. Ni. Ni dia punya ni. Yang solid ni you tak payah bother lah. Yang ions ni. The coefficients are very important. You miss out, that means your Q will be wrong, your E cell also will be wrong. Okay? Alright, so this is the final equation. So you have the value already. The number of electron is 6 electron. Okay, now Q. Nak settlekan Q banyak kerja sebenarnya nurse ni. Settle, dah cari Q, this is the formula. Okay, ni equation yang you dapat. Kenapa? These are the equation that you got just now. The overall equation after you have multiplied with a factor just now. So you product over reactant. Okay, product over reactant. So Q is equal to this one kita tak include. Okay, product is Cr3 plus kuasa 2 guys over reactant Ni2 plus kuasa 3. See? Jangan tertinggal. See? So once you have identified this one, you can simply get the value from the question just now, insert into the quotient just, and the rest are all mathematical. Okay, semua matematik dah tutukan kalkulator, yang 4 ni je yang you nak identify. Berapa soalan? Ada berapa soalan sebenarnya? Okay, right. Cubalah try checkpoint 7. Okay, and then the next checkpoint tu, that will be your homework. Okay, we will discuss it tomorrow, and I'll proceed to electrolytic cell. At least sikit kita masuk pun jadilah. Ini to warm up. Okay, to use Nernst equation. Make sure that you ada that first step on how to use the equation. First step dia apa? Adalah tulis equation tu sendiri. Ya, silakan. Checkpoint 7. Okay, 3 minutes guys. 4 minutes lah, 4 minutes. Need to go to the toilet, okay? Okay, right, jom. A voltaic cell consists of silver plus silver atom, silver plus ion, silver atom, silver solid, half cell with concentration of 0.1 molar, and the other half cell is the same with concentration 10 molar at 25 degrees Celsius. So this is pretty much the same as what we had for copper just now. Okay, so we have the same electrode, the same ions in the solution, but they only differ in terms of concentration. Okay, all right, so we have 0.1 and the other one is 10 molar. This is E naught, or this is the E reduction potential for silver. It is given 0.80 volt. Okay, all right. So first you have to determine the direction of electron. So we have one solution is more concentrated than the other. Okay, all right. So as what we have learned just now, the electron will be moving from the less concentrated solution, which is from 0.1 molar solution. Be specific, okay guys, which is the anode. Okay, the anode punya part, anode punya side, to the more concentrated solution, which is 10 molar, okay, which the reduction takes place ataupun which the cathode is immersed in. Itulah maksudnya determine the direction of electron. Okay, from less concentrated to more concentrated. Calculate the initial cell potential. Okay, alright. As you can see, the concentration given are not at 1 molar. Okay, so definitely both of them need to be at 1 molar in order to not use the Nernst equation. I mean, we can just simply use the E0 cell at standard condition. If one concentration is 1 molar, the other concentration is not at 1 molar, is still Nernst. You still need to be using Nernst. Okay, kena dua-dua at 1 molar baru boleh pakai, baru tak payah pakai Nernst. Okay, alright, so you have to use Nernst. Ada 2 soalan. Okay, this one yang take home punya practice. Okay, electron flow from less concentrated half cell to high concentrated half cell. The electrode in less concentrated, dia ada cakap. Dia suruh explain why. Macam tak ada determine the direction of electron. Okay, rupanya ada kat sini. Explain why. The electrode in less concentrated electrolyte has more negatively charged because Ag electrode get oxidized to form Ag plus and leaving behind their electron on the electrode. This is exactly what I have mentioned to you just now. Okay, macam mana, kenapa less concentrated tu dia dekat anode? Kenapa tak dekat cathode in the first place? Okay, because the Ag from the electrode will will jump into the solution, will get into the solution, will oxidize, okay, will oxidize and becoming Ag plus and leaving behind the electron on the electrode, and this electron will be moving through the wire and go to the cathode, okay, and then electrode, and then the electron will be accepted by Ag plus. Bila Ag plus accepts the electron, it become Ag solid, Ag atom. Okay, so tapi dia nak tanya macam mana elektron tu bergerak daripada anode ke cathode. So sampai situ je lah. Okay, alright, calculate the initial cell potential guys. Okay, you are still going to be using Nernst, tapi E0 cell tu senanglah sikit sebab electrode are both electrode for anode and cathode are the same. So you will get 0 lah. Value dia tu dia akan tolak kan, jadi dia akan dapat 0 lah. So sini 0. Ni you kena be careful. Okay, siapa atas siapa bawah, this one is not a problem. This one satu Ag kan, Ag jadi Ag plus. So siapa atas siapa bawah ni confirmkan from the tadi kita dah buat conclusion kan, dia akan yang product more concentrated, yang reactant less concentrated. Ke yang mana satu tadi? Check balik lah. Okay. Right, so that is all. So we have like 5 minutes. Okay, so maybe we can have this 1 minute to take a deep breath. Jangan banyak bercakap sangat. Okay, madam jangan menggunakan tenaga yang berlebihan. Okay. Alright, so tone down, everything kena tone down. Tapi make sure dia efficient. Okay, so far do you have any question related to Nernst equation, related to previous subtopic just now?
No, madam.
Tak ada So far so good. Bagus. Walaupun yang jawabnya seorang aja. Yang lain tu tak tahulah kan. Ada soalan, tanya. Okay, jangan tunggu-tunggu, tanya. Tanya sekarang. This is the time. Don't worry. Macam aku seorang je ke tak faham? No, yang lain pun tak faham kat tu. Dia malu lah tu. Why not you do a favor, tanyalah. Okay? Okay, kejap 1 minit 1 minit. Okay, alright, so let's start. This is the last subtopic for topic 4. Alhamdulillah, we are almost coming to an end of this topic. Okay, so we have 3 learning objective for this subtopic. Okay, this is electrolytic cells and its application. So we are done with electrochemical cell. Okay, galvanic cell, voltaic cell, and whatnot. So we are done with that. So next we have electrolytic cell. Okay, so we have 3 learning objectives. Make sure that you covers all. Okay, you cover all. Okay, I'm sure that you already have the familiarity lah on this topic. You dah ada that familiarity. You are familiar with electrolytic cell, with voltaic cell. Okay, so this is like a revision lah ataupun a recap. Okay, on electrolytic cell. Okay, so electrolytic cell. Electrolysis is a chemical process that uses electricity for a non-spontaneous redox reaction to occur in an electrolytic cell. Okay, all right. Remember just now we learn on how to determine the spontaneity of a reaction. Okay, if it is a positive value, that means it is a spontaneous reaction. If it is a negative value, if the E0 cell is negative value, that means it is non-spontaneous. Non-spontaneous means it will not happen as is. Dia tak akan terjadi macam tu. Sebab dia non-spontaneous, it will not happen that way. It will happen the other way around. Yang mana yang sepatutnya berlaku. Okay, but if we would like, if we want the non-spontaneous reaction to take place, we still want the non-spontaneous reaction to take place, what we can do is that we supply battery atau we supply energy, because to force a non-spontaneous reaction to take place, you have to, put effort. Okay, macam kita sendirilah, kalau you ada preference, you ada hobi you. Kalau you suka membaca, okay, you tak suka memasak. Okay, so kalau parents you nak suruh you buat, you can do whatever you want today. So you would choose reading over cooking, right? Tapi kalau parents you nak suruh you memasak, okay, maksudnya parents you kena put effort dekat situ. Kena umpan you ke, okay, kalau kau masak hari ni, mak bagi RM50. Macam tu. Itu yang kita put effort. Maksudnya to make the non-spontaneous, maksudnya you will not be doing the cooking. Okay, tapi in order to do the cooking, you need something to push you. Okay, to push you to do the cooking. Okay, contohnya mak you bagi RM50 ke RM100 ke, bagi you hadiah ke something. That will push you to do cooking. Okay, to cook. Samalah juga ni. If you want the reaction, the non-spontaneous reaction to take place, you have to supply something. You have to supply energy. In this case, the battery. Battery is like the external source that you put into the cell so that it helps it helps for the non-spontaneous reaction to take place. Okay, all right. So that's the idea of it lah. So it is known as electrolysis. Okay, it is made up of two electrodes immersed in an electrolyte, which is the same as what we had in galvanic cell. We have two electrodes immersed in an electrolyte. Tapi we only have one electrolyte. Okay, for electrolysis cell, electrolytic cell, we normally have one electrolyte only. But for galvanic cell, we have two electrolytes in separate container. Okay, all right, anode connected to the positive terminal of the battery, so it will be positively charged. It is different than galvanic cell. Anode is still where the oxidation takes place. They still sama. Cathode is where the reduction takes place. Okay, it's just that dia punya charge dia berbeza. Kalau galvanic cell, the anode is negative charge sebab dekat situlah elektron sebenarnya terkumpul dulu sebelum dia move to cathode. So that's why the anode in galvanic cell is negatively charged. Okay, but in electrolytic cell, it depends on the terminal of the battery. They depend on the connection to the battery, how it is connected to the battery. So if an anode, normally it would connected to the positive terminal of the battery. Cathode pula to the negative terminal of the battery. Okay, so dia akan rely on the terminal of the battery lah. Okay, right. So battery, we need to have battery. Okay, it's a source of direct current pass through the electrolyte. So this is like a pump lah. Dia nak non-spontaneous kan? So you have to add in battery. Battery is like a pump. Dia tarik the electron out from dia paksa. Battery itu macam external source, effort. Paksa the reaction take place. Okay, forces the electron to flow from anode to cathode. But there's still oxidation to reduction. Okay, electrolyte contain cation and an ion, either molten salts or aqueous solution of salt. Okay, so electrolyte need to have the cations and anions lah. Right, so this is basically how electrolytic cell looks like. So you have battery, you have anode and cathode, and then you have electrolyte. Okay, so you have on cathode we have reduction, on anode we have oxidation. Okay, alright, ni macam ni. This sodium plus accepts electron becoming sodium. Like I said kan, sodium prefer to become sodium plus. Dia tak prefer becoming sodium. Okay, they prefer to undergo oxidation and becoming sodium plus. So nampak tak, in electrolytic cell, dia force this reaction to happen, which naturally ataupun spontaneously it won't happen. Okay, tapi in electrolytic cell boleh berlaku. Macam Cl minus. Okay, Cl prefers to be in Cl minus state, tapi kita paksa dia jadi Cl2 chlorine. Okay. Okay, alright. So rasanya that's the only slide yang kita boleh cover lah. Okay, so this is just to highlight the difference in electrolytic cell dengan galvanic cell, and then the similarities which I have highlighted just now. Tapi this is in proper slides. We have it in one slide. Okay, so let's stop here. So we continue tomorrow. Okay, so we have one hour for tomorrow's lecture. So that is all. So thank you everyone for your attention. Okay, see you guys tomorrow. Assalamualaikum. Bye.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.